Welcome back, ladies and gentlemen, to a summarizing Theory B, calculating with square roots. Nothing new here, but quite a lot of theories that we've discussed previously. With previously, I mean mostly in second grade. We also use those in different paragraphs, but this is actually just a summary of almost a whole chapter, chapter 1 in second grade. With all the rules for calculating with square roots being discussed yet again. Which rules, for example, root a squared is equal to a. Remember, a root and a square cancel each other out. Root a times root b is the same as root ab. And if I have roots of a and roots of b divided, that's the same as taking the root of that whole fraction. And you're just going to practice with this again, with exercises like this. Minus 3 root 2 squared. Remember, here both things get squared. So here minus 3 is being squared and root 2 is being squared. Minus 3 times minus 3 is 9. Root 2 squared, the root and the square disappear. It's 2. And 9 times 2 is 18. Well, if my minus 3 was outside of the brackets, of course, it was not going to be multiplied by itself. The square is not going to be applied to the minus 3. Things like this, root 2 times root 7 is root 14. 2 root 3 times 5 root 7, multiply the numbers in front of the roots, 2 times 5, and multiply the numbers inside the root, 3 times 7, and they say it's 35. I think this is an error, right? Because 3 times 7 certainly is not 35. The book contains a lot of, well, mostly translation errors in this paragraph, but this is quite frankly just a mathematical error. 2 times 5 is 10. 3 times 7 is not 35. It's going to be 21 inside of this root here. Root 15 divided by root 3 is the same as root of 5 because I can just do 15 divided by 3. Right? You can first divide them if you want to. And here 6 root 10 divided by 3 root 2. 6 divided by 3 is 2 and root 10 divided by root 2 is root 5. That's this rule. Let's continue on because we have more rules to discuss. For example, the fact that like square roots can be collected, they can be added up. Like square roots were roots with the same letter or number inside of the root. So this is possible. 3 root 2 plus 5 root 2, you add them up, you get 8 root 2. Subtraction have the same rules, so if the roots are like, you can subtract them. But if they are not like, for example 5 and 2, inside the roots are not the same, you cannot add them up like this. Well, not like this. Sometimes you can actually factorize and then you can. For example, if you're going to take a look at root 18 plus 5 root 2, remember we can factorize this. We kunnen een factor voor het wortelteken brengen, noemen we dat in het Nederlands. Root 18 can be rewritten as root 9 times root 2. Remember this long list that I asked you to memorize in second grade? We're going to use that again. We're going to rewrite this big root here into two smaller roots. And one of those roots have to come from this list here. And I always want to rewrite it to a multiplication involving or consisting of the biggest root of this number. We're going to take a look at that later. But first here, we all agree that 18 can be rewritten as 9 times 2, right? So root 18 can be rewritten as root 9 times root 2. Why do I do that? Root 9 can be calculated mentally. Root 9 is 3. So this becomes 3 root 2 plus 5 root 2. And now they can be collected. They can be added up. I'm going to skip this example here, but I'm going to take a look at this one. If you have a quite big root like this, root 72, sometimes it can be factorized in multiple ways, but not really actually, because some of them are not completely factorized yet. You always want to rewrite, we want to factorize it in such a way that you take the largest square, so that means the largest number in this list on the left, times a number. So here 72 you want to factorize as 36 times 2. which will become 6 root 2. Because if I would rewrite it to 9 times 8, right, and I take the root of 9 and the root of 8, the root of 8 can still be factorized, so then you have to factorize again. And here the same way, 18 can be factorized again. We saw that right here. So to avoid factorizing multiple times, we want to factorize in one go by just taking the largest square from this list here. Okay, this might maybe need some exercise by some people. You have to practice this again. That's okay. That's what this paragraph is about. And that's disagreement, right? When you are simplifying square roots, use the largest factor possible. And then we get questions like this again. So let's quickly glance over them. If we have something like this, if everything is inside the brackets, everything is being squared. Here the 4 is outside, so the 4 is not being squared. So this becomes 25, because that's 5 squared, times 3, because root 3 squared, the root and the square, you see that happening right here, disappear, so that's just 3. Here minus 4, 4 is not being squared, 5 is, right, root 5 squared equals just 5. And you can do this. This is the difficult part, the first step, using the rules for calculating with roots. The second one, if you have something like this, don't be intimidated by this. Divide 18 by 6 and root 80 by root 2 will give you this. Check, however, if you can factorize this root here. Can you? I think we can, because we can rewrite root 40 as root 4 times root 10. Why do we take root 4? It was in that list that I previously showed you, and it's in that list because I can actually calculate root 4. That's 2. And then we don't have 3 root 40 as our final answer, but 6 root 10. And you have to do this. So practice. The first thing that you take a look at here is, if I have a simple subtraction, are they like roots? Here they aren't. Why? The numbers inside of the roots are not the same. But don't give up yet. Maybe I can factorize something. And I cannot factorize root 3, but I can factorize 27. In what way? Well, in this way. 27 can be rewritten as 9 times 3. So root 27 can be rewritten as root 9 times root 3. Again, root 9 was in that list that I showed you on the previous page. Root 9 is 3, so now I can rewrite it to 4 root 3, which I still had, minus 2 times 3 times root 3. And then you get this, and here I have like roots. So here I can do 4 minus 6 is minus 2 root 3. Okay, and then the last one, simple, a multiplication of roots. Here, multiply the numbers in front of the roots and multiply the numbers inside of the roots. 18 root 20, but check if you can factorize that root. Can you factorize that root? Yes, you can, because 20 can be rewritten as 4 times 5. So root 20 can be written as root 4 times root 5, and root 4 is 2. So this becomes 36 root 5. Nothing new, but quite a lot, and for some of you also quite a long time ago. So practice this again. This is quite important, and we'll come back next year. Doesn't matter which type of mathematics you choose, it will come back in A, it will come back in B, and it will even come back a bit in C. Okay, and D is going to be in 5th grade. So practice, practice, practice. And theory C I'm going to explain in the next video. Good luck!